All right, guys, we are now on lesson 4 and 5. I appreciate everybody coming in, and thanks for watching those the first 3 lessons. We've had a bunch of people do it. Let's make sure we keep on rolling with this and checking your work every single lesson each day, Monday through Wednesday. All right, so today we're moving on to adding and subtracting whole numbers. So we're going to knock out 2 lessons today, and we're going to do lesson 4, using strategies to add and using the standard algorithm to add greater numbers. All right, guys, so we're going to look at our first sheet right here. The directions say add using different strategies. So basically, I mean, the one strategy that we were teaching you guys, just using the standard algorithm, man, just adding your ones place, your tens place, your hundreds place, and then your thousands place. I'll show you kind of what I do in my head on a couple of the problems, but for the most part, I'm going to be using the standard algorithm. For example, we look at number 1, you have 4,000 plus 6,215. Well, automatically, it's easy to add numbers to 0, so I can quickly do my hundreds place, 215, and then I know 6 plus 4 is 10. So my sum on this one would be 10,215. All right, so let's cruise on to number 2. Number 2, we have 4,010 plus 6,215. So at first, I'll show you the standard algorithm. Your ones place would be 5, the sum. Look at my tens place, the sum would be 2. My hundreds place, the sum is 2. And then my thousands place, the sum is 10. So we get a total sum of 10,225. If I were doing this in my head, though, I would subtract 10 from my top number to get 4,000. And then I would add 10 to my bottom number to get 6,225. Now I can quickly add whole numbers to 0 and get 225. And then my thousands place, the sum would be 10. So that's just one of the strategies that you could use for there. All right, and then I'm straight up using the standard algorithm on this one. My ones place, the sum is 6. My tens place, my hundreds place, and my thousands place. So we get a total sum of 10,336. All right, guys, let's check out number 4. I can quickly add my hundreds, tens, and ones place because 0 plus 871 is 871. And then my thousands place, my sum would be 9. My total sum is 9,871. All right, so if we look at number 5, so what I would do on number 5, I'll first start out with a standard algorithm. 9 plus 1 in my units place is 10. We cannot have 2 numbers in one place, so I would bring my 1 up to my tens place and put my 0 in my ones place. And then 9 plus 1 is 10, plus 7 is 17. Carry my 1 to my hundreds and put my 7 in my tens. And then 1 plus 9 is 10, plus my 8 is 18. Carry my 1 to my thousands and put your 8 in your hundreds place. And then finally we have 6 plus 3 would be 9. So we get a total sum of 9,870. So let me go ahead and erase this right here. An easy way to do this, guys, to make your life a lot simpler, I would add 1 to this and subtract 1 from this number. So then we have 3,000 plus, actually let me go ahead and equals, and then we have 6,870. So now it's a lot easier, man. 870 plus 0 is 870. And then go ahead and just add up your thousands place, and you get 9. 9,870. All right, final one. Just use the standard algorithm. You have 1, 14, 15, 16. A 6 in your tens place. Carry the 1 to your hundreds, and then you have 10 plus 8. Should be 18. Put your 1 in your thousands and your 8 in your tens. 6 plus 3 would be 9. 9,861. All right, and then if you want to go through, make it a little bit easier for yourself, I'm going to go ahead and add 10 to here, which would give me 3,000. Now, if I'm adding 10 to the top number, I'm going to subtract 10 from here, which would give me 6,861. And then we go to add those together. I quickly know 861 plus 0 is 861, and then my thousands place, my sum would be 9. So we can see we have the same sums. All right, guys, cruising down to number 7. Standard algorithm, add up your ones place, add up your tens place, carry your 1 to your hundreds, and your hundreds place would be a 5, and then your thousands place would be a 6. All right. On this one right here, add up your ones, add up your tens would be 18, put the 8 in the tens and carry the 1 to the hundreds place, and then 10 plus 4 is 14, a 1 in the thousands and a 4 in the hundreds, and then my thousands place, my sum would be 6. All right, if you want to do this, use a different strategy, and you don't have to do it this way, guys. Standard algorithm is fine. I'm just trying to show you different methods to do things. So we can add a 10 to here to make it an even 5,000. And then if we add 10 to the top, we have to take 10 away from the bottom. And then you would end up with 1,481. So now when I'm going to add these numbers, I can quickly say 481 plus 0 is 481. And then add your thousands place and you get 6. So we can see we have the same sums. If you don't get what I'm doing over here, guys, just stick with your standard algorithm. That's fine with me. And then the last one, we're just going to use the standard algorithm. Add up your units place, you get 1. Add up your tens place, you have 14. 1 in the hundreds and 4 in the tens. And then 10 plus 4 is 14, so put a 1 in the thousand and a 4 in the hundreds. And then we have 4 plus 1 would give me a sum of 6. 6,441. All right, guys, number 10 says, what strategies did you use to solve the problems? Explain. So basically we use the standard algorithm, the way that we've been doing addition forever. And then we try to simplify it and make it easier by adding 10 to a number and then taking away 10. Because anytime you're adding numbers to 0, it's much easier. And then you quickly know what 5 plus 1 is to get 6,481. All right, number 11, it says check your answer to problem 6 by solving it with a different strategy. Show your work. All right, guys, so we're going to check our answer. So we would simply take our sum, put it up top, and then take one of our add-ins, and we're going to use subtraction. All right, 1, look at my units place. 1 minus 1 is 0. 6 minus 7 you cannot do, so you have to take 1 from your hundreds place, which changes your tens place to a 16. 16 minus 7 is 9. And then you go to your hundreds. 7 minus 8, we cannot do that, so we're going to take 1 1,000 from here, and we're going to bring over 10 100s. So now instead of having 7 100s, we have 17 100s. 17 minus 8 will give me a difference of 9. And then finally, in our thousands place, we have 8 minus 6, which will give me a difference of 2. And you can see that the add-in up here matches my difference down here. So we have checked our work. All right, guys, page 8. We're going to estimate the sum of each addition problem to check if the student's answer is reasonable. If not, cross out the answer and write the correct answer. So the first one right here, you can see we rounded 8,997 to the nearest thousands place, which would be 9,000. And then we rounded 2,301 to the nearest thousands place, it would be 2,000. We add those two together to get a sum of 11,000. And you can see 31,998 is nowhere close to 11,000. So we cross it out, and then we will use the standard algorithm to go ahead and add these numbers. Start in your unit place, you get 8. Units place, you get 8. Go to your tens place and you get 9. Go to your hundreds place and you get 12. So put your 2 in your hundreds place, carry your 1 to your thousands, and then 8 plus 2 plus 1 is 11,298. And we can see that 11,298 is very close to 11,000. And if we were to round it to the nearest thousands place, what we would do for my lesson last week, we would underline that thousands place and we'd circle the place to the right. The circled digit is the boss, and a circled digit is 4 or less. So the underlined digit stays the same. All the digits to the left will stay the same, and all the digits that are circled and to the right will turn to a 0. All right, let's check out number 2. 23,411 rounded to the nearest thousands place would be 23,000. And then 35,507 rounded to the nearest thousands place would be 36,000. Add those together. 0, 0, 0. My thousands place would be 9. My 10,000s place would be 5. 59,000 is nowhere close to 12,918. So let's use that standard algorithm to work it out and see if we're close. My units place would be 8. My tens place would be 1. My hundreds place would be 9. My thousands place would be 8. And my 10,000s place would be 5. So let's go ahead and round this to the nearest thousands place. Underline that thousands. Circle the digit to the right. The circled digit is 5 or greater, so my thousands place will go up. All the digits to the left of my underlined digit stay the same. All the digits that are circled and to the right will turn to a 0. All right, very good. Cruising on to that next one. 72,418 rounded to the nearest thousands place would be 72,000, and 41,291 rounded to the nearest thousands place would be 41,000. So add those up. 0, 0, 0. My hundreds, tens, and ones. My thousands place would be a 3. My 10,000s place would be 11. 113,000 is very close to that number, so we are good to go. I would say we have the correct answer, but let's go ahead and work it out anyways to see if it is the exact answer. My ones place, my tens place, my hundreds, my thousands, and finally my 10,000s. And we can see we have the exact answer. Very cool. All right, guys, next one. I can already tell just by looking at this number, we are nowhere close to 10,000. I'm going to go ahead and cross that out. We are going to go ahead and add this guy up. 3 plus 2 is 5. Tens place is 4. My hundreds place would be 12, so put a 1 in the thousands and put a 2 under your hundreds. And then 8 plus 3 is 11. And then my 10,000s place would be 7. So 71,245. If I were to round this number to my nearest thousands place, we'd have 68,000. Round this number to the nearest thousands would be 3,000. Add those together. We get 71,000. Now, if I were to go here and round it to the nearest thousands place, you underline the thousands place, circle the digit to the right. The circle digit is the boss and it is 4 or less, so my thousands place stays the same. All the digits to the left stay the same, and all the digits that are circled and to the right will turn to a 0. So we're good to go on this one. All right, guys, look at our last one on this page right here. Here again, I can tell this one's going to be way off just because I know 9 plus 5 is 14, and 14 is nowhere close to 6. So I'm just going to go ahead and work it out. All right, so we start off in my ones place. We get 12. You get 11 in your tens place. You get 2 in your hundreds. And you get 14 in your thousands place. All right, so let's round 5,188 to the nearest thousands place would be 5,000. 9,024 rounded to the nearest thousands would be 9,000. Add those together, you get 14,000. If I were to round 14,212 to the nearest thousands place, you underline that thousand, circle the digit to the right. Circle digit is the boss, and the boss is 4 or less, so the underlined digit stays the same. All the digits to the left will stay the same. All the digits that are circling to the right will turn to a 0. 14,000 and 14,000. All right, guys, let's cruise on to page 9. This just continued on from what we just did. Yeah, I can tell that the student answer looks pretty close. Let's go ahead and round it and see what we got. 21,822 rounded to the nearest thousands place would be 22,000. All right. And then 75,333 rounded to the nearest thousands place would be 75,000. All right, add those together. 97,000 is very close to 97,155. Let's just go ahead and check it anyways and see what we get. My ones place, tens place, hundreds place, thousands, 10,000s. And we can see we're right on. All right, cruising on to the next one. I know 60,000 plus 60,000 is going to be well over 100,000. So crazy answer. Let's go ahead and round 60,125 to the nearest thousands place. 69,205 rounded to the nearest thousands place would be 69,000. Add those together. Hundreds, tens, and ones stay the same. Thousands is a 9, and 10,000s is a 12. We have 129,000. All right, so let's add them up, see what we get on our problem right here. 5 plus 5 in my units place is 10. Carry the 1 to your tens place, put a 0 in your units place. We have a 3 in our tens place, a 3 in our hundreds place, a 9 in our thousands place, and a 12 in our 10,000s place. So we're rounding this number to the nearest thousands place. So we're going to go ahead and underline that thousands place, circle the place to the right. The circle digit is the boss, and it is 4 or less, so my underlined digit stays the same. All the digits that are circled and to the right will turn to a 0. All the digits to the left of the underlined digit stay the same. All right, let's check out our very last one here. I mean, I can already tell if I rounded each one of these to 10,000, I mean, I knew each one of these, that would be 30,000, and 30,000 is a lot less than, this is over 100,000, so that's not going to work. All right, so let's go ahead and round this to the thousands place. You get 5,000. You get 5,000. All right, and then the last one to the nearest thousands place, 9,296. We'll round to 9,000. Add all those together, and you get a sum of 19,000. All right, let's go ahead and add these up and see what we get. My units place, I'm going to go ahead and add these two together. You get 10 plus 9 is 19. My tens place, so I'm going to go 10 plus 9 is 19, 20, 21. And then add up my hundreds place. This is going to be 10 plus 2 is 14. And then we add up. I'm going to go ahead and add my 9 plus 1 to get 10. And these two added together would be 9. So 10 plus 9 is 19. 19,419. And if I were to round this to the nearest thousands place, go ahead and underline my thousands place, circle the digit to the right. The circled digit is my boss, and it is 4 or less. So my underlined digit stays the same. The numbers that are circled into the right all turn to 0. And then the numbers to the left of the underlined digit will stay the same. All right. So guys, how does estimating an addition problem help you know if an answer is reasonable? This is basically what I do in real life. When I'm going through buying stuff, I know how much money I have, and I will round everything up as I'm purchasing it. And then that way I have a roundabout figure if I have enough money to spend for the day. I mean, instead of adding everything up exactly, it's gonna be very time consuming, and sometimes you need to get your answers quicker than that. So rounding is definitely the way to go before finding your exact answers. And then, number 2, can an answer be incorrect even if it looks reasonable, and explain. So on this problem, number 2, yes, can an answer be incorrect? Yes, it can be incorrect even if it looks reasonable. You'll never know until you actually work the whole problem out to see what the correct answer is, but yes, even if if it looks reasonable, it can still be incorrect until you work the whole problem out. Well, I just want to say thank you very much, guys. I'm super proud of each and every one of you. You guys are working hard. Keep up the good work and keep on cruising, guys. And can't wait to see you tomorrow. You guys take care and have a good evening.